I'm Cheng Chi Hong, and I'm now going to talk about Mock 2 Q1 Question D. A financial analyst is interested in the percentage of revenue spent by computer software companies on research and development. A random sample of software companies is selected, and the results are summarized in the following table. A 99% confidence interval has to be constructed for this question, and also assumptions and approximation has to be provided. First, we have to calculate the mean and standard deviation for this set of data. For the mean, it is 8.362% and standard deviation of 1.737%. Since the standard deviation of the population is known and it has a large sample size of 50, we can use this equation to apply to these questions. And it is a 99% confidence interval, so alpha equals to 0.01. And now we have to substitute the mean of 8.362, alpha 0.01, and standard deviation of 1.737 and sample size of 50 into the formula. After the calculation, we will have the answer of mu1 equals to 7.7292% and mu2 equals to 8.9948%. So the 99% confidence intervals is 7.7292% and 8.9948%.
This is Mengjia Yang, and here I'm going to talk about Mock 3 Question 4, Part A. The question is, a sales manager would like to compare the recent performance of two salespersons under his supervision. From the sales record, their daily sales were normally distributed with the same mean and standard deviation were $200 and $250. The amount of sales of 10 days in the sales record will be selected randomly for each salesperson. Calculate the probability that their mean daily sales will have a difference of at least $150. Apparently, the nature of this question is sampling distribution of difference of means. We assume mu1 and mu2 be the mean of their daily sales, sigma 1 and sigma 2 be the standard deviation of their daily sales, and n1 and n2 be the selected sample size from the daily sales respectively. According to the question, mu1 minus mu2 equals to 0, sigma 1 is 200, sigma 2 is 250, and n1 and n2 equals to 10. Since the standard deviation sigma 1 and sigma 2 is known, the target object of this question, x1 bar minus x2 bar, is also normally distributed as follows. According to the sampling distribution of difference of means, the mean of x1 bar minus x2 bar equals to mu1 minus mu2, and the variance of x1 bar minus x2 bar is the square of sigma 1 over n1 plus the square of sigma 2 over n2. Here, we put the known statistics into the formula and get the mean of x1 bar minus x2 bar is 0, and the variance of x1 bar minus x2 bar is 10,250. To simplify, we let mu0 and sigma 0 be the mean and standard deviation of the new normal distribution. The saying that their mean daily sales having a difference of at least $150 exists two possibilities. First, x1 bar minus x2 bar is bigger than 150, which is mu0 is bigger than 150. Second, x1 bar minus x2 bar is smaller than negative 150, which is mu0 is smaller than negative 150. And therefore, the probability of this question equals to the probability of mu0 is bigger than 150 plus the probability of mu0 is smaller than negative 150. Here, we transform the normal distribution into the standard form, which is 2 times the probability of z bigger than 150 minus 0 over the square roots of 10,250. Finally, we calculate the equation and get the final answer, which is 0.1388.
So, good morning, everyone. my name is Renpei and I'm going to elaborate Mock 3, question 4, B, and C. So let's take a look at question B. In evaluating customer satisfaction level, a company would like to be 95% confident that the error in estimating the population mean does not exceed 0.05. If the population standard deviation is 0.8, what is the sample size required? So firstly, we can know that it's a 95% confidence interval. So by dividing by direct substitution, we can know that the value of alpha is 1 minus 0.95, which is 0.05, and the alpha divided by 2 is 0.025. So by using the normal distribution table, we can find the z value, which is 1.96. And we assume that the customers are more than 30 people, so we can use the first formula to build a confidence interval, which is given below. So the estimation of population mean does not exceed 0.05 because of the sample median lies in the middle of the interval. So according to the definition, that these value is no larger than 0.05. So by divided substitution, we can know that n is bigger than 983.4496. But because n is an integer, so the minimum sample size is 984. So let's take a look at question C. In a random sample of 500 clerical employees from a large multinational company, 300 said they would like the company to adopt a flexible scheduling policy, which would permit employees to decide when and how much they would work. Construct a 90% confidence interval to estimate the population proportion of clerical employees favoring the flexible scheduling policy. Explain briefly how the confidence interval should be interpreted. So firstly, it's a 90% confidence interval, so we can find the alpha value, which is 0.1, and alpha divided by 2, which is 0.05. And by using the normal distribution table, we can find the z value, which is 1.645. So by using the information given above, we can calculate the sample probability, which is 0.6. So because of the sample size is bigger than 30, so we can use the first formula to construct the confidence interval. And by the value substitution, we can get the confidence interval, which is between 0.564 and 0.636.
Hi, this is Michelle, and I'm going to talk about Mock 4 question 4a. In a study of turnover rates of new employees after a 1-year period, 150 new employees from various departments are selected randomly and 29 of them are no longer employed after the 1-year period. Construct a 98% confidence interval for the turnover rates. This question provided us with two numbers, 150 and 29, and asked us to construct a 98% confidence interval for this turnover rate, which is a confidence interval for a proportion. And here is the general formula for finding the confidence interval for a proportion, where P represents the sample proportion, 29 out of 150. We have to find out all the unknowns in this question, where P is 29 over 150, and 1 minus P is this number, and alpha is 1 minus 0.98, which is 0.02, and 0.98 is the desired confidence level. And we also have to use the Z table to find out what's C, 0.02 over 2, and N represents the sample size. By direct substitutions, we can put in all the numbers in this formula and find out the two answers for constructing a 98% confidence interval, which are 0.118204 and 0.268462. Thank you.